Hello and welcome to Enhance Observability of your intelligent apps on AKS. This is the third in our series around building intelligent apps with AKS. I'm Stephen Morawski. I'm a principal cloud advocate here at Microsoft. And today I'm joined by Casey Yu. Casey is one of our program managers working on AKS. Casey, you want to just tell folks just a little bit about yourself, some of the things you focus on?
Sure. Thanks, Stephen. Hello, everybody. I'm Casey. I'm part of the AKS product group, as Stephen mentioned, and I mostly work on cost management, cost optimization type features for AKS. And super excited to, dive into today's session and talk about some very fun capabilities.
Great. If we could just get to our slides for just a moment. Fortunately, we don't have a lot of slides today, but we do have just a couple. So if you do want to follow along with what we're going to be doing, the AKAMS link is right up there on the page, or you can snap the QR code, and that should get you going as well. Now, there isn't a Learn Sandbox or anything for this lab, so you'd have to do this in your own subscription. And if you wanted to include the OpenAI portions, you would need to get your subscription whitelisted for that, join the preview for that. But we're going to go through and show everything here, and feel free to go back on your own time and do the parts that are interesting and exciting for you, or that could help you out in your environments. But the link for the instructions, if you just want to follow along with us, are right there. Now, next up, housekeeping. We have Paul Yu, who is going to be in our chats wherever we are. We're streaming on YouTube on a couple of channels, and on the Microsoft Developer Twitch. And Paul is there helping get your questions to us. So if you have any questions as we go along, Casey and I are happy to jump in and try to answer some of those for you. And Paul is there helping make that happen. Now, this is live and interactive, so please do, chime in and chat, say hello, ask us questions. This ultimately, we've got some information to share and show, but you can help us make this even better. All right, we've got a couple of learning objectives for today. Our first is how we want to use Prometheus-style metrics with Azure Monitor. We're going to turn on Azure Managed Prometheus so that we can get all the benefits of Prometheus with a lot less actual management tasks that we have to do to maintain that. We're going to look at how we can visualize application and infrastructure state with Azure Managed Grafana. And finally, and I think one of the more interesting bits, we're going to take a look at AKS Cost Analysis add-on and look at the view that gives us into how our AKS environment is performing. And if we have time towards the end, I was able to work out maybe a little bonus section that if we can, where we can maybe wire up some of that open cost driven data into Azure Managed Grafana via Prometheus. So that was a bit of fun to do, and could give you some interesting ideas on how you can take advantage of that, the Prometheus metric scraping as well. All right, enough of the preamble. The application, I just want to cover a little bit about the application environment that we are going to be using. We're not going to spend too much time in the app itself, but we'll be seeing a lot of the details of that app as we go through the features that we're enabling today. So you may, if you were with us for either of the last 2 weeks, you'll recognize this architecture diagram. And this is the AKS Store Demo app. There's a storefront, there's a store admin, there's a chat service that helps, in the store admin, helps people add in new products. We've got multiple different services running inside of our AKS environment. In fact, the whole thing, other than the OpenAI integration, our Azure OpenAI Services integration, is actually running in AKS. So, all right, with that, let's move over to, All right, I need to restart my code space here. So while that's restarting, it should start up relatively quickly. We are going to start with the AKS Store demo application, and you can find that out on GitHub. It's in the Azure Samples GitHub org, and it's also linked in the labs. And I've already started the setup of this so that we don't have to wait for AKS to spin up, because that can take a couple of minutes to get a whole new environment up and running. But we've spun it up. There is we're using the Azure Developer CLI to spin up the environment. And so if you're looking at the instructions, we're actually on step 3. So I've got the deployment of my environment set, and I'm now going to, well, first I'll show you what, so when we use the Azure Developer CLI to create the environment, it stores it creates a bunch of, what doesn't it like about me? I didn't say help. So look at this. I'm going to restart my shell because something's not behaving right. All right, let's try this again. AZD, ENV. So I've got a couple of environments. The environment we're using is the BIA, Building Intelligent Apps. And so let's do AZD and get. There we go. So it create when you use AZD, it can create a bunch of environment variables for you, and it uses those for the commands that AZD runs and populates them for things you want to use later. So I can easily get them into my shell environment, or at least easily once the commands respond to the words that I type, by just evaling that, and that's gonna make all of those environment variables available in my shell session. There we go. All right. So that way, if I would, just to verify that these loaded in, deploy Azure AI, that should echo out true. All right. So I know I've got the environment variable set the way I want. So the next thing I need to do is ensure that I can access the AKS cluster that we provisioned. Now, we're going to use the AKS get credentials command, and I'm taking advantage of some of those environment variables that were provisioned, so that I can just give it some environment variable names. I don't need to necessarily spell out the AKS cluster name, so I don't need to go look that up or run a command to go find it. Just taking advantage of those environment variables that are available. All right, so if I do kubectl get pods, and the pets namespace is where we deployed everything for the service. And I can see I have my whole application environment running there. All right, everything's up and running. Everything's working as expected. So now we can move into how do we add some better observability, some additional monitoring, logging around our AKS infrastructure. Now, Casey, have you ever, you talk to customers a good bit, right? And do they ever, mention anything about challenges with observability or anything along that line?
Yeah, 100%. There are many challenges, I guess, within observability. For example, there's a technical side when you're managing and kind of have to monitor many clusters, many applications. How do you do that in a way that is easy to interpret from, the number of logs or metadata that you have? And then there's also the operational side of the challenges where, it takes special tools. You need folks kind of trained to kind of help configure these tools and manage the data. So when it comes to observability, there are a lot of great options and tooling that can help. And some of the managed tools that we'll kind of walk through today are super great options if you don't want to leave the Azure ecosystem. You want everything kind of directly in your Azure portal that you want to view your data. So yeah, we'll talk through Managed Prometheus and Managed Grafana, which are super awesome tools for kind of understanding your cluster health, performance data, and then how to troubleshoot it as well if there are issues with your AKS workloads.
Yeah, and there's a lot of moving parts into this whole thing, and there's some really good documentation in the Microsoft Docs over on learn.microsoft.com. And at the very end of the workshop, I've got a number of links to document to the docs that go through like how to set some of these things up. And so one of the first things that we have to do, so before we can wire up Prometheus and Grafana with our AKS cluster, we first need an Azure Monitor workspace and Azure Managed Grafana. Because if we have those two things existing to begin with, it's the tools can help us wire them up more effectively, and we don't have to go chasing around to actually try to get these things to talk together. So the first thing we're going to do is we're going to create an Azure Monitor workspace. Now, there are 3 different kinds of workspaces so that come into play when we're talking about all of this container monitoring and AKS monitoring. So, and I always get confused as to what's what. So there's an Azure Monitor workspace, and that's what's going to store the Prometheus metrics that we scrape. There is going to be a Managed Grafana workspace. That's where the kind of the data that gets stuffed into Grafana lives. And then there is a log analytics workspace, and that's where Container Insights, which is something we're going to talk about in a little bit, where it stores all the logs. So like your text stream logs. So there's 3 different workspaces that come into play here, and it's okay if you get a little confused by them, because I definitely do, and I always have to go back to my notes and like, okay, what goes where, and but once you have them all wired up together, we'll see in the Azure portal later, the portal helps us bring those things all together, so you don't have to go hunt them all down. They're all just there for you at the AKS, when we have AKS in place. All right, so now let's get our Managed Grafana in place because our workspace has been created. Oh, so I also have. Let's make this one 2. I've also created a whole environment, and I got it up and running a couple days ago, so that we could collect some data about it, so that when we actually go to look at the dashboards and things like that, we'll switch over and look at a different instance that actually has some historical data behind it. So that's where it was telling me I've already used that name. So we'll just make a quick tweak there. Now it's provisioning out the Grafana environment, and the nice thing about the managed service is Grafana provides a tremendous visibility and query infrastructure that can tie to a number of different data sources. But if I'm working for one of our customers, our share price probably isn't going to do much better if we can run Grafana really, really well, right? Now, the data coming out of Grafana might help me run other things that are important to our business very well. But if I can take advantage of the managed service and reduce some of that operational overhead on my organization, and we can focus that on the things that really, really matter, it's a win. And so I think that's where like this Azure Managed Grafana really comes into play. It also helps you wire into different Azure data sources really well, like specifically Azure Monitor, but also Azure Data Explorer have very nice connections in. Have you gotten to play much with Managed Grafana, Casey?
A little bit. I really like the pre-built dashboards that kind of the managers have. So you can just really easily, you know, have a pre-built dashboard, see the key metrics that you kind of are important to you, and then you can use that as a launching pad to go troubleshoot or go optimize your cluster, and you don't have to spend all this time configuring it, creating your own custom dashboards. Obviously, that's a feature you can do, and that's something you can do if you're interested in it. But yeah, it's a lot of fun.
Yeah, and there are a good number of pre-built dashboards that we can go use, and we'll go take a look at some of those after we get these things up and running. But and then we can and obviously you can extend and build your own. You can build your own dashboards to show specifically what you want and provide the most value to your development and operations teams. All right, there we go. Oh, we've got it provision. Aha, there we go. All right, now we can move on. So now we've created those workspaces. We need the workspace IDs both for Grafana, or the Grafana ID and the Azure Monitor Workspace ID. So I'm just going to collect those and store them into some local variables. And it helps if you update the name to the name you actually used. There we go. And then we're going to set our AKS cluster up to use both the Azure Monitor repository and be able to provide metrics to Grafana. And the Azure CLI is going to do a lot of help for us here. You can do a lot of this through the Azure portal. The docs that I have linked at the end have walkthroughs for the portal as well. So we're gonna update our AKS cluster. We're gonna pass in a command or a flag to enable Azure Monitor metrics, tell it which cluster and resource group, and then we give it the workspace ID for Azure Monitor and the Grafana resource ID, and then the command can go behind the scenes and connect everything up for us. And once that's all connected up, that's going to help us get the Azure Managed that enable Azure Monitor metrics is setting up that Azure Managed Prometheus for us. And once that's in place, we will have data that we can go work with. But there's a couple other things that we're gonna add in before we go dig at some of that data. We're going to enable. There's a preview feature to get the control plane metrics as well. So not just the metrics about the workloads that I'm running, but about how Kubernetes itself is operating, behaving. And there are dashboards in Azure Managed Grafana that help us take advantage of that information, so we can see how how etcd is doing behind the scenes. Can give us some additional visibility into how the managed portion of AKS is behaving. And so, because occasionally, if we were to see, some challenges in scaling particular workloads, or maybe we're deploying a lot of different microservices into individual clusters, we might want to be aware of how the managed side, the the management control plane is doing. And so the turning on the control plane metrics gives us a way to get some really good visibility into that. Now so this is
Yeah, there are some really awesome new metrics that are kind of exposed through this feature. You get to see like kube scheduler metrics, cluster autoscaler to understand how like actually your cluster is scaling up and down. I think you mentioned etcd as well. There's some metrics on that. Yeah, it's like a whole new you get a whole group of new insights on how the control plane is actually working, how healthy is it, how performant. It's awesome.
Yeah, and for a long time, people were asking for that kind of information, right? Because AKS does a really good job of kind of abstracting away having to care about some of that.
Mm-hmm.
But there are edge cases where you do have to care about some of that, or it would be at least helpful to understand and be able to visualize better some of the things that were happening. And yeah, you could go and you could run some commands and figure some of these things out, but some of them you couldn't. Some of them were just not available at all. All right, so we've updated our AKS cluster. We've connected in Grafana and our Azure Monitor workspace. So we've now enabled the managed Prometheus. We can verify that by checking to see if the metrics collectors are running, and they are. So since that is up and running, we can move on to this next part of enabling the control plane metrics. And because it's a preview feature, and it's not like just one of the standard out of the box features, we have to register a feature. Now there are two steps when we go to turn on new stuff inside of Azure. First is feature registration, and I've already done this, so it comes back. Usually, it takes a couple of minutes to enable a new feature. And if you're waiting, there's a show command, so you could actually watch and check back periodically to watch the state. We already show registered, so we can kind of move on. So we have to turn the feature on, and then we have to re-register the provider so that it picks up that new feature for us. Turn on the feature, re-register for the provider, and now we are off to the races. Now, what's interesting about this is to get this going, all we have to do is update our cluster, and because we've turned this feature on, when we update the cluster, additional metadata will be provided, and it will just turn on those control plane metrics, which will start getting scraped then. So we haven't provided any arguments, so it's just asking, hey, do you just want to verify these existing settings? Yep. And what that's going to go do now, like I mentioned, is actually enable those control plane metrics. All right. While that's running, let's hop over and actually take a look at the Grafana dashboard and see some of that data that's been coming out. So to get to the Grafana dashboard, we can go into our resource group. The one that we're provisioning out right now is this guy right here. And we can see we've got our managed Grafana, we've got the Prometheus rule groups, we've got our Key Vault and Kubernetes service, the things that were deployed earlier. And Learn Live Grafana, that's the new one we deployed. Now to get the other data, or to get the data that I've kind of been building up, we're going to go to the resource group that I provisioned earlier in the week and go to that managed Grafana. And we can find the endpoint there. There's also a CLI command in the instructions to go find the endpoint. I've already got it open for us over here. And when you land on this dashboard, there won't be any recently viewed because it's the first time you're landing there. You've got these nice helpful things here at the start, but and just to make sure, I am by no means a Grafana expert. So, but I can fumble my way through. And when I did, I found the fastest way for me to get to the pre-built dashboards is go home, go to dashboards, and we've got these folders here. And the two main ones that we're going to look at are the Azure Kubernetes Service Monitoring and the Managed Prometheus folder. And as you can see, there's a good number of dashboards, that are provided here. And we're just going to peek in on a couple of these just to see kind of the information that comes back, what we can see through this, and then we'll look at what it takes to go and start building a custom dashboard, and then we'll move on to our next step here of container insights and getting our logs and what we can do with that. All right, so let's take a look at. Now, I don't have some metadata tagged to my cluster, so it's looking for some tags for role and instance, and wasn't finding those. But you'll see all of the actual data that matters, like CPU utilization and memory utilization and all that. Those are populating. It helps though too if I change, because our core workloads is in the pets namespace, and that's going to help. There we go. So now we're seeing the data that I was expecting. Now, for this particular, to get some actually nice little graphs showing and things, I actually increased the virtual workers and customers inside that deployment so that there was lots of activity. So we've got fun spiky graphs to look at. And memory utilization, like this is
They
like
look beautiful.
Yeah. I mean, you can see, there's a lot of top level information about kind of the physical system resources in this dashboard. We can look, network traffic across things. And then if we had application insights wired up for our application, that can all surface here as well. And of course too, we can, change the time scale. If we want to look, the last 12 hours and change change how that looks. We can, now the other section of dashboards that are, and that's just the out of the box Azure Kubernetes service. You've wired up your Azure Monitor, you're good to go. The Managed Prometheus specific ones, they get a little bit more detailed and focused. So like if we wanted to look at our workloads by namespace, we can take a look, and so we can see the stuff that's happening in kube system. We can take a look at our pets namespace, and it's going to drill down into into these metrics that have been collected.
And the really great thing too is that this is like all real-time data. So as a developer, you're making some changes, you're deploying your application. It's really easy to see the impact of that in real time and make adjustments, and rather than having to wait like retroactively until there's some big issue and then you have to go debug. So this is a super great tool to use side by side as you're kind of developing.
Yes, and so it's real time. I'll just put a little caveat on there. So there's a refresh window for the dashboard, and so it's auto refreshing every minute. And then there is there's a cycle time on how frequently Prometheus is scraping metrics, right? So there is a slight lag, but it's around a minute at most. So So if you have a big spike and you're not seeing it right away, it'll be there. Just take a breath, grab a drink of coffee, and and you'll likely be seeing it. Some of the other things that were showing up in the managed Prometheus dashboard. So if we look at overview, now where is? There's a dashboard I was looking for, and I had it earlier. Maybe it still is in the. Oh yeah, the etcd and the API server graphs, right? Like, so the etcd one, if you are doing lots of config maps and sharing lots of data around inside your cluster, and you have a lot of different environments running, the health of etcd could be very, very important to you, right? Helps with the service discovery and all that kind of fun stuff. And so being able to see how etcd is performing inside your cluster can be very, very helpful to your awareness and to the your ability to respond to challenges. Hey, because if there is a problem with etcd, you're probably going to have to engage support, because that's not something in AKS that you can go manage yourself. All right. Now we've had a chance to kind of look around and see some of these different dashboards. We also have the option, we can go create new dashboards. And when we do that, and this is kind of really hard to see probably down here in the corner here, but you can pick your data source, and we can go manage Prometheus, we can go Azure Monitor, we have other data sources that we can tie into. But when you pick a data source, all of the metrics that are available from that data source, you can pull into your graphs, and you can do different graph types, and there's a bajillion different settings and ways to make the visualizations and things. I like picking just like a simple simple graph like this here, and as I grab metrics, I'll just run the query and kind of see what that data looks like. Let's the container file system read bytes total, and what does that data actually look like? We just hit run, and so you can kind of explore visually what that data looks like and see how it's partitioning those up, and then you can create additional filters and off of there to refine that data down to being just what you want to be showing. And hey, is this data mostly looking flat? Is it mostly, is it actually, spiky? Is it, you'll get a much better feel for what that data looks like as you explore. And, you can, using the time window, adjust that range so that you have a reasonable amount of data to work with for what you're trying to, see. Now, that's Steve's how to explore a little bit of data in 30 seconds in Grafana. There's obviously much better longer form resources and how to create cool dashboards with Grafana. But picking your data source, and then just kind of scrolling into and looking through all those metrics, getting a visualization of them really can it takes some time, but it can turn out some very cool reporting. All right, let's jump back to our shell, and we see we've had our update applied. So our cluster that we created today is now collecting all of those control plane metrics, and so those things are all going to be available from that data source that we were just from that Prometheus data source that we saw in Grafana. So our next step in improving our visibility here, and the things we're talking about in terms of improving this visibility, it's all managed services so that you're getting this really nice increased view of what how your services are running, behaving, how the infrastructure hosting them is behaving, without adding a lot of operational overhead to yourself, right? And to me, that's one of the key things to this. Now, so setting up container insights. Container insights is what's going to and my shell is not responding. All right, let's open a new one. I was probably talking too long. Casey, you just got to stop me if I keep talking. That's why you're here, to just kind of interject every now and again, and because you're way more interesting than I am.
No, I loved following along your demo. That's a good one.
All right, this is going swimmingly well here. All right, well, I'm going to restart this code space, I think. Here. Well, there's no restart command, so let's stop the current code space and fire that back up. While that's spinning up, we'll go and take a look at some of the things that this add-on enables for us, because like I said, I set one of these up the other day. So in the resource group that I set up the other day, and if you're wondering how we get those fun named, like unbiased Malamute, or what was the other one? The other one's Fluent Asp. The infrastructure as code that spins this up is in Terraform. There's a module in Terraform that generate these, kind of wild pet names, or not pet names, but wild animal names. And so if you go into the AKS store demo application or GitHub repo and look at the infrastructure as code, the infra folder, actually I can show you, since hey, I've got this here. There is Terraform, and I think it's in the main. Random pet. Yeah. So there is this random pet resource, and that is what gives us these fun names to be used. So let's see.
I love it. So, sometimes naming things is the hardest part.
It is, and so I will credit Paul on for the for the clever use of the naming bit in Terraform there. But and now the shell's up, so we might as well kick this off, and then we'll pop back over and look at while this is provisioning. So, to set up the container insights is extremely simple from the Azure CLI. We're just going to enable the monitoring add-on, and it will create the log analytics workspace for us, unless we can provide one, just like we provided the Azure Monitor workspace before. But there's no special benefit to doing that ahead of time, unless I've already got one in place that it doesn't like the environment variables if you don't actually load them, because this is a new shell session. So there we go. Now we'll try this again. All right. But so it will create the log analytics workspace for us. We could, like I said, you could, if you have one already or you want to create one ahead of time, you can. That way you get a little more control about naming and things like that. But for our purposes here, the command does all the wiring up that we need. So we didn't need to do that. Whereas with the Azure Monitor workspace, we wanted to be able to pass in that resource ID along with the Grafana, so all that stuff could just get matched up. So all those connections could be made for us. All right. So we're back in the unbiased Malamute resource area here, and we've got monitoring set up. So that lets us go to Insights, and that helps us gives us a view into our AKS cluster. So we can go kind of take the roundabout way there. But here we go. Now this looks better. All right. Well, we get, some not as pretty as Grafana, but we get a lot of the same graphs and information, but not in as customizable a format. We still have the same filters. They're both pulling from the same data source, right? Like these metrics are all being scraped by Prometheus. They're being stored in Azure Monitor. We have some reports that we can run on all of the various, all the various things here. One of the more interesting reports is our cluster optimization. We'll take a look a little bit closer at that in just a bit, but we get a view into our nodes and their performance, containers, controllers. We don't have to go to each one of these things, but in order to ramp up our cost for a later demo, I provisioned a whole bunch of nodes in this node pool, way more than it needs, so we can see that like the utilization on these things is pretty low. But even though I've got a number of pods deployed. So one of the other things that setting up that Insights enables for us is this workbooks. And workbooks are a great way to bring your troubleshooting guides, your playbooks, whatever you want to call these things, in close to the resources that you're working with. So when you do have an issue, you have some defined reports or process guides or anything for looking at particular issues, along with the relevant graphs and the relevant metrics that you need to help figure things out. Now, there's a number of these things that are provided for you just to get a little view into things. The one I want to look at right now is this cluster optimization report, because this is something almost everybody could benefit from. Now, there are a couple of things that the optimization looks at. Number one, looks liveness probe failures. So, do you have proper liveness probes set up, and are your pods responding to those things, right? So it goes through and looks at all of the things running in my cluster that have liveness probes set to them, and shows like, hey, this one's red here, right? So maybe I need to look into this guy, right? So total is the total failures over that time range, and the controller total is how many of the probe failures from all containers managed by a particular controller. So what it's telling me is basically that my make line service, its liveness probe is the source of all of my problems. So I probably need to go do something about that. Actually, Paul, if you're paying attention, maybe you need to go do something about that, right? Paul's actually he's the chief engineer that's been behind the AKS Store demo app. So nudge, maybe you need to go look at that. It's probably due to the load that I'm having put on the make line service. So I wouldn't worry too much about it, Paul. All right. Then there's event anomaly. So we can see, some of the things that are happening inside of our cluster. Let's make a little more room here. Right. So we can see some of the events that are happening inside of our cluster that we can go investigate and figure out, right? And then the last thing that I want to look at here is this container optimizer. Now, this is pretty cool because it looks at the workloads that you have running, and it looks at the thresholds that you have set for the CPU request limits as well as their maxes, and as well, and then the utilization of those. So it looks like for the most part, the greens they're in good, they're within thresholds that were provided, but it looks like we've got a couple that are one that's kind of in a warning state and one that's really not happy. Let's take a look at that one. Now, have you dug into this one at all, Casey?
I actually have not played with this yet, but it's
Yeah.
super cool because requests and limits are typically like quite hard to get right. If over
It's like dark
provision,
magic.
if you under, yeah, and it's also the source of a lot of, I guess, cost wastage, so to speak. For example, if you over provision and the requests and limits aren't set right, then you're going to be having a lot of idle resources that can be better utilized, and that might cause your costs to spin up. So seeing that there is an actual like recommendations here and kind of this tool can really help customers like nudge it in the right direction.
Exactly, right? Like, so you can see, what's the, what are the suggested limits? What are the, what's been the max usage? What's the max request that it should be able to ask for? And this can help guide you in setting those thresholds for your workloads to help them perform optimally, right? And and you kind of get this all in context for the rest of your app. And we can see, we got the store admin here, and here we just get the raw numbers and not a nice pretty graph. But this can help, you get that suggested memory limit to add, the suggested request, memory request bytes. So we can go back to our deployments and fix these things so that they run closer to expected, or we can at least make an informed decision, right? Like, even if we're not going to make the changes, we at least can say, okay, well, this is what I'm allowing. This is what it's asking for. Is there a reason for this? Because maybe it's not maybe this isn't, I need to fix the template, the deployment template. It's maybe I need to look at what's happening inside that container, because maybe that's unexpected behavior. Maybe it shouldn't be asking for so much memory, or it shouldn't be using so much compute, right? Or if I'm seeing it not use the memory I expect, or the compute I expect, is everything happening that I expect to be happening, right? So it gives us that additional context for how things are actually behaving in production, or whichever environment we're in as we're looking at. Hopefully in production is not the first time we're looking at this, but hey, if it is, it's better to have that information than not. And just for turning on a feature that you get this kind of help is, I think, it's a really easy trade-off. Okay, so that's kind of our run through of insights, and it should be finished configuring. And yep, of course, and we can verify inside of our cluster that new stuff is running. So we're going to look for the AMA logs. And because that's what collects all of the logs from our containers. And and there's one other service that is running. I think that's the reporter. So it takes those logs and ships them over to the log analytics workspace. Like I said, so many workspaces and so many.
Yeah, I still get confused with the workspaces. I need to triple check when I'm setting them up.
Yep. Yeah. So we got the Azure Monitor for the metrics, workspace for the metrics. We've got the log analytics workspace for our logs, and we have the Grafana workspace. That one's the easiest one for me to remember because
Yep.
that's just for Grafana. But the log analytics and the Azure Monitor one, I always kind of like, which one do I need again? Or I thought I had one of those. So, all right. So we went in and we took a look at at our Prometheus data already. I mentioned that there was a CLI command to get that URL, and here it is, right? Like, so do you use the Azure CLI much, Casey?
I jump between, when I'm setting up like new features, new clusters, we'll try to learn through CLI and play around in Portal as well. Usually CLI experience is quicker.
Yeah. So one of the things that I found as I use the CLI is that it can be really, really helpful. So a lot of people will take the output because the default output's in JSON. And so a lot of people will pipe that output through JQ to be able to filter down and get to specific properties. Well, the Azure CLI command offers a query parameter that, while it's not exactly the same as running it through JQ, can give you some similar behaviors. And it uses, what is it? Is it JSON? No, it's not JSON path. The James path, yes, JMES path syntax to query. So you can filter results that come back. You can ask it for specific properties. So in this case, we're going to ask it for the properties endpoint. And then we can change the output type. So by default, it goes to JSON, but there's tab separated values, or there is a table. And so by doing tab separated values, I get rid of the JSON bits of the curly braces and the property name and the quotes and stuff around things, which can be really helpful if I was saving this into a variable. That's actually what we did earlier when we got the workspace IDs and the Grafana ID. Is we used that query along with we use the query along with tab separated values to just get the raw string, and so we could pass that along. Just a little tip: James path can be kind of frustrating when you're figuring it out, but if you do a lot of stuff with the Azure CLI, it can be very, very helpful long term. So just something something I've bumped into and has been helpful to me, but has also caused me much pain. So like when you run a list and maybe you've got 500 things in that list, trying to get the query, the filter syntax correct, so I just see the things that I care about. Because the way you filter arrays versus the way you filter other like just single results it can be a little challenging, but yeah, overall it is a very helpful syntax. Okay, so we've got our Grafana up. We've talked about dashboards, the baked in ones. We talked about how you can start exploring creating your own. Now I think we get to talk about one of the to me, we kind of buried the lead, and one of the more interesting things that's been happening with AKS, like we know Prometheus, you could wire it up yourself before. Now we have managed Prometheus. That makes it easy. Great. log collection, great. We've known about that. But one of the things that we've been doing, and Casey, you've been extremely instrumental in kind of the shepherding of this process, is we've been working with the open source project OpenCost and improving the way that we can look at our cost data to get a better understanding of how our clusters are operating.
Mm-hmm.
And
Mm-hmm.
so I'm gonna start this setup, and I'm just gonna quickly talk about how we set this thing up, and then Casey, anything you want to share as we go, and we'll dive in and look at what it looks like once that's up and running, because my cluster did start collecting data, and it's got
amazing.
it. And I was really happy to see that, because it takes a little while to get started. All right, so to get this feature set up, we have to do our feature registration, and I've already done this, so this will come back fast and say registered. Like I said, those things can take a few minutes to do, and there's a show command in the instructions so you can check the status as it's going. Then we need to update our AKS cluster, and we're going to pass in the flag enable cost analysis. And that's going to go off and do all the things. And we can check this later. But I want to, yes. So you have to have standard or premium as your tier for your cluster. So, and I forgot that when I deployed this cluster. So, we are going to update our cluster, and fortunately we can do it in the same command and enable the cost analysis. And that is a note I have to make sure I add that qualification in the lab, because that was what I was trying to remember the other day and I couldn't. Yeah, so we have to go to at least standard here. So now this is off and running. So Casey, what do we need to know? What do we need to know about this?
Yeah, so I guess for some context, this is a new not private, it's now in public preview feature of AKS, and it's meant for cost visibility, cost allocation, and just understanding what resource costs contribute to your top level AKS cluster cost. So when we kind of built this feature, we partnered with OpenCost. It's actually built on top of OpenCost for resource, container node resource metrics collection. So we know, okay, this node consumed this much CPU and memory versus this is how much was requested. And then we are able to reconcile that data with your actual Azure bill. So the invoice data that you see at the end of the month, for example, we break that down and then give you a view within Azure portal to visualize that experience.
Should we look at that?
Yeah, let's jump into it.
All right. So we're back into the Azure portal. And let's close it. Did I lose my full screen? Nope, there we go. All right. So to get to this, we have to navigate in from the subscription level, correct?
Right, that's correct.
Yes. All right, so in my subscription, I have, there's cost analysis, right under cost management.
Yeah, so cost analysis is an existing feature of cost management experience. We've just augmented it with supporting for Kubernetes granularity. So if you go in that view, exactly, and there's a Kubernetes cluster, this will take you to the full suite of the new AKS views that we've added. So this is kind of the main Kubernetes overview. You'll be able to see all the clusters across resource groups, regions, and their aggregated cost for that period. So right now we're looking at March, but you of course can kind of filter the date if there's a particular time frame that you want to do the look back for.
Yeah, now this cluster's only existed since Monday, so obviously I haven't racked up too much in charges. I was actually surprised with how low it was, given the workload that I deployed. So I was kind of happy about that. So unfortunately, we can't scroll back to other time periods, but because there's only that, and I only have the one cluster on board. The other one's onboarding right now. But there is a lag. It takes about a day to start showing up in this view. So I was actually pleasantly surprised when I checked in on it and saw, hey, I've got my cluster there. I can see I can see my resources. So if we expand the cluster out, it goes in and breaks down. Where some of these costs are coming from disk, from public IPs. Can I change the? No. I was looking to see if I could slide. Oh, maybe I. There we go. Let's slide that over so we can. You just got to be very delicate about how you find the line there to open that up, but it tells you, what the meter is that you're working with. That's my public
So
IP
here's
addresses
kind
tagged
of
yeah.
It's like a bill of materials, or I guess bill of resources that are in your cluster, the underlying infrastructure resources. So your virtual machine sets for compute, for storage, we have disks, PVs, and then for networking resources, we have things like public IP, private IP, public endpoints, a whole bunch of resources that are kind of fundamental for running your cluster and running your workloads.
Awesome. Now there are other views into this, and the best way that I found, and maybe Casey, you have a different suggestion, but just clicking on the ellipse next to the cluster lets me look at see the views for Kubernetes namespaces or Kubernetes assets. So, you have a preference as to which one we look at first?
Let's do namespaces. I'm curious about that one.
All right. Let's see. Can I? Looking to see if I could, reduce some of that the top of the screen up. But unfortunately, I can't. So we'll scroll down here a little bit. So we have some idle charges. We show kube system, system charges, service charges. This looks like a plane ticket. Yeah, this service charge and that service charge. And we've got my pets namespace and unallocated charges. And it looks like most of my charges are coming from idle charges. And there's a little, so that's a portion of resources that are not allocated to any workload. And that makes sense because, as I mentioned, I provisioned out a bunch of nodes to help run up the bill so that there was actually some numbers to look at. And whereas the workloads deployed, just there's not enough to really saturate the CPU, the virtual machines that are allocated.
Yeah, and this is extremely valuable, especially in like multi-tenant shared cluster scenarios where multiple teams might be sharing a single cluster. They might have their own applications in different namespaces. So when you have that top level view of, okay, this team is responsible for these namespaces, which are incurring this much cost, it kind of helps promote this sense of, I guess, accountability across the dev teams and application owners to be cognizant of what costs that they're actually spinning up for their applications.
Yeah, and idle charges actually seem to me to be like an important thing to keep an eye on, especially whether or not you have multi-tenant clusters. If you have multi-tenant clusters where you have multiple teams deploying into and you're trying to proportion out costs, the idle cost is a good thing to keep in mind. But if I'm looking at my workload distribution across clusters, if I'm seeing high idle charges on clusters, maybe my workload distribution isn't quite right, or maybe my scaling rules are, now we have that node auto provision. Maybe I need to take that for a spin, because maybe there's times of day where I can spin down some of those resources, and times of day, or even patterns to the week, right? Like that's an opportunity for savings.
Absolutely. Yeah. Node auto provision is a super cool new feature too that can help you select automatically the right VM SKU type for your workload based on, utilization details, based on cost factors. And that can really help you save on, especially if you have high idle charges where, that's opportunity, that's basically money that you've already paid for the resource that you can take advantage of. So node auto provision is a great feature to help with kind of reducing that idle and improving utilization.
Yeah, and looks like there's some interesting stuff I'm gonna have to explore one of these days in the Ellipse. Every now and again, I just go click on something and and see new stuff popping up. Let's take a look at that asset view. And
one new, I guess, other cost management capability you should definitely check out is in that ellipses. It's still a preview feature from cost management, but you can actually hit that try preview, and you can kind of select which preview features you want to try out. And one that I like is the charts in cost analysis preview, and that'll actually show up above these table views that you see. You can see a day over day kind of historical chart trend of the cost as well. So it's just another way to kind of visualize the data. But over the long term can yield some pretty interesting insights, especially if you have jumps in cost or any anomalies. Easy to identify that way.
all right, so let's. Oh, I see a graph. So let's go to Kubernetes assets, and unfortunately, I still have this big, huge top area that's taking up part of our screen. But we got this nice little stacked bar showing compute is the greater part of our costs, and networking, and yeah, it's cool. Thanks for showing me that preview feature. It's I was looking at some of those the other day. I'm like, should I turn any of these on? I'm like, oh, I better not though. I don't want to throw like Casey off. Like, hey, what's going on? I didn't see this.
Yeah, some of those features are not specific to the Kubernetes views, so they're, I guess, part of the cost management suite of capabilities. So once those kind of mature to GA, they just automatically propagate to all of the cost analysis views, and that would include Kubernetes. So it's kind of like a free win for this experience.
Yeah, and if you're first exploring cost management, one thing to know, like, is you have about a year's worth of data there. I think it goes back 13 months, but that's all the data. Like, so if you wanted to go back 2 years in data, that's not gonna work. So you're gonna, but you can schedule exports if you needed to pull this data into something else. It's all available via API. So all of that is, all of that's accessible to you should you need longer time windows. But if you're starting to look at the cost data through cost management, you do have up to about a year of data. Now, this cluster only has a day, or a little over 2 days worth of data, but it's what we have to work with. So the asset view looks like it breaks it down by like general category: compute, networking, storage. What's unallocated charges?
That is basically any lags. So the process with how we match up utilization data and the bill material, or the billing info, sometimes there's a lag, so that might fall into this bucket. There's also, if you're using Defender charges, that is kind of its own Azure service category. So right now that is captured in the unallocated bucket, since it doesn't fall into compute, network, or storage. So these charges, Defenders build on the, I think, per node. Yeah, it's a per node license fee versus the aggregated like VMSS fee that compute is reported at, which is why we'll see it there.
Okay. That sounds good. Yeah, so there's my scale set.
And then, yeah, for each of these kind of meters and resources too, we see that idle charge used and the system charge as well. So we can see, okay, this VMSS in particular, if you have multiple node pools or multiple VMSS in your cluster, this one in particular has extremely high idle and very low utilization. That's a big opportunity.
Yeah. And we can also see, how much is being used by the system behind the scenes too, which is good, right? So I kind of get a view of how much was used by my workloads versus how much is used by the infrastructure supporting the Kubernetes deployment. Then we got networking. Yeah, there's like everything in here. I got my public IPs there. Our disk. Now service, that's just the Kubernetes service itself, right?
Mm-hmm. Yeah, that would be the uptime SLA fee for like standard tier clusters. It's 10 cents per hour per cluster, so that's also included there.
Okay, and we needed that just to turn on the cost analysis feature. So because you have to be on standard or premium. All right. Is there anything that we've missed about these new cost management capabilities, or the experience working with the Open Cost project, or anything that that was? So we've got our deployment going, and I just wanted to quick show this. So to show that it's running, we can look inside of our cluster. I almost forgot that little bonus bit that I wanted to try to show. So we have a deployment here, and I'm just going to get to the top here. It's the cost analysis agent, and that's what gets deployed into the kube system namespace and is doing, and in conjunction with other parts of Azure, this works with that to do that cost analysis breakdown for you, right? Is my understanding correct there? Mm-hmm. Okay. Now, one fun thing, if you're a Grafana person and you want, or even if you're you like your Prometheus data, you can set up custom scraping, and there's a config map that you can apply to enable custom scraping. That's all shown in the lab. Let's get that little YAML file here. The important bit for that is there's some pod annotations that you can apply to tell the managed service that you should scrape metrics from it, and it's this regex here where you can tell it what namespaces just by doing the period star that's saying all the namespaces. I could just say kube system or whatever regex you want to provide for namespaces to use. So if I apply that, that tells the managed Prometheus instance now that, hey, yes, you can go scrape other things. And I can annotate my pod with three metrics. And I'll show you what the YAML looks like, because that's easier to see than the JSON that we'll supply with the command line. But we tell it to scrape true. The path is metrics and the port. And we can do that without changing much else in the deployment by doing the kubectl patch deployment command and passing in a JSON version of that little configuration that I showed you. And by doing that, we have now told our managed Prometheus to scrape the metrics coming out of the OpenCost instance. And so we can see some of that data, and I'll show you the data that's coming out of that. I'm doing a little port forward. We'll go to our browser. And so we can see that the data, this is the data that's being made available at the metrics endpoint that Prometheus is then coming forward and going to scrape. And there is a lot of it. I'm just going to scroll here. We'll drop down. So, we get container resource requests. We've got, what else? This is a lot of stuff here. Now, this is not nice, pretty JSON, but you could always pull it out and get that. And then there's some annotations and things to help Prometheus along the way as well. But node hourly cost, there we go. Tells us what the architecture is, all the fun details that we would need to know. Gets us little meter readings, and so I could then now go into my managed Grafana and start looking at, I could add this into my reports. So I could start layering cost data. Now, this isn't going to line up exactly. Casey was setting me straight the other day. It's not going to line up exactly with what's in cost management.
Yeah, there might be some slight differences. So within cost management, since we're essentially breaking down your bill, your invoice, and slicing it in a Kubernetes-centric way. So the costs that you see in Portal are, as accurate as possible to line up with your actual invoice bill. With OpenCost, they are using, they use different cost management APIs, and it's more of a bottoms-up approach where they merge your utilization detail with, rate card API or price sheet API. So it's not going to be 100% apples to apples just because the reconciliation process is different. But if you do want, that Prometheus or Grafana opportunity to visualize some of that data, then you can definitely use them side by side.
Yeah, it'll give you some directionality, right? And maybe you could layer it alongside some of your performance metrics, so it can give you that additional context for how our applications are performing and behaving, because maybe we're seeing, especially when we start layering application level metrics alongside that. So I can start to see, from my application, maybe it's transactions completed or whatever, but I could start to see some of that alongside of how much it's costing to do that. And that can help me make scaling decisions. That can help me make resource utilization prioritization decisions, whether or not we need to invest more in how our process behaves, because maybe it's not worth doing the additional performance tuning on our application. It's cheaper to throw more resources at it, and we get a sufficient benefit, right? So if I don't know what these things cost, then it's hard to make some of those decisions.
Mhm. Yeah.
So
And I think this also just hits on like why is monitoring and visibility from the metrics perspective, performance, cost perspective, why is it so important is exactly that. It gives you opportunity to understand where your clusters, where your resources are at right now, and then what next steps can you take to improve.
yeah. So just to kind of recap what we covered today, we've installed managed Prometheus, we configured container insights, we installed and used Azure Managed Grafana, we wired up AKS Cost Analysis, and we looked at taking that open cost data and exposing it to manage Prometheus. So therefore, it could be used in Grafana or really any other. We could still use it in Azure Monitor in queries directly against Azure Monitor. Azure Monitor also now with the managed Prometheus supports their PromQL query language. So you could do Cousteau or you could do the PromQL queries against that data, which is pretty cool. There are a couple of things before we kind of wrap up that I want everyone to be aware of. So this is number 3 in a series. So you can find out more about the rest of that series over at azure.github.io, cloud native, build, IA, learn live. It's part of our Building Intelligent Apps series. You can connect with us over at the AKS community on YouTube. You may be watching us there. This video will be recorded and available there. It's also available at the Microsoft Reactor YouTube. And if you are going to KubeCon EU, we have 2 things to be aware of, and it's coming up pretty quickly. So March 18th, there is AKS Essentials Day, and then we have an Azure Pre-Day on March 19th. So if you are going to be there and you want to join us for those, there's the AKAMS links for those 2 things there. We'd love to see you there. We'd love to get a chance to be with you in person. Unfortunately, I won't be able to be there, but members of our team will be, and yeah, we'd love to get a chance to spend a little time with you and talk about Kubernetes.
Yeah, and if you were interested in any of the topics today, at the pre-day, there will be 2 dedicated sessions. One completely on monitoring and observability, deep dive into Prometheus and some of the other Azure Monitor capabilities. And then also a second session completely on cost management, optimization, talking about, scaling, infrastructure selection, how that can all help with your cost optimization strategies. So yeah, would super love to see any of you there if you are able to.
Awesome. Well, I'd like to say thank you to our producer Anna, who's been helping out, Paul, who has been our moderator in our chat, and I really want to thank you, Casey, for joining me today to help talk about these fun topics.
Thanks for the opportunity. It's a lot of fun.
Oh yeah. And most importantly, those of you who joined us to watch or are coming to watch afterwards, really glad you're interested in observability on AKS. And if you have questions or feedback, please don't hesitate to drop us a comment. And yeah, we'll talk to you soon.